Okay, so this is kind of a review because you guys kind of understand the linear, nonlinear just when we did the first day of scatter plots. But we're going to look more in depth at linear versus nonlinear just so we understand it a little bit better. And so when we look at these first couple graphs, graph A and graph B. So graph A, you want to look at to see if it's linear or nonlinear. Could you draw a straight line through most of the points? No, we can't. So that means it's non-linear. Because the linear has the word line in it. So if you can't draw a straight line in it, then it's non-linear. This guy, however, we can draw a straight line through most of those points, so that means it's linear. So then number 1 says list characteristics of a graph that suggest a linear relationship. So the characteristics of a graph that's going to suggest a linear relationship, first of all, there's going to be a constant rate of change for the most part. And it'll look like a line. Or you could draw a line through your points. Does that make sense? Because here I can draw a line through the middle of those points, and from that I could find a constant rate of change. I could find a rise over run like we do with slope. Okay? So then on the second one, list the characteristics of a graph that suggest a nonlinear relationship. So if the graph changes directions, like on this first one, it went up and then it went down. So if it changes directions, if there's a curve and it doesn't look like a line. Okay. Then on number 3, contrast the relationship between x and y for graph A and graph B. So for graph A, so just because it's not linear doesn't mean it doesn't have a relationship. So, or an association or a correlation, all those words that you guys have seen. So for graph A, the relationship between x and y, it increases, like the points go up, and then it decreases. So I'm going to say increases, then decreases, because my points, they all kind of go up in a positive manner, and then they drop, they go back down. And then for B, it is increasing at a steady rate, and it's linear. So all of my points, even if you couldn't see the rest of this graph, if you were going to predict what was going to happen, you would say that there's going to be some more points up here somewhere. They're going to keep going. So then let's look at graph C and D on the other side. Graph C, we could pretty much draw a line through most of those points. It looks like a line, so that's linear. Graph D looks pretty linear, but this thing here at the end, it kind of curves. So since I can't draw a straight line through it, nonlinear. And so contrast the relationships between x and y for graph A and C. So A and C. Okay, so A and C, we're looking at all of the graphs now. So the relationship between A was that it, like we talked about earlier, A increased, then decreased, and there was a curve. Okay, so it went up and then it went down like a roller coaster. And then, so C, as opposed to graph A, decreases at a steady rate. Ooh, I misspelled steady. Hello. At a steady rate. And it's linear. So if you can predict the points that are going to come next, you would say that they would be somewhere down here. You can kind of see what's going to happen. Number 5, contrast the relationship between x and y for graphs C and D. Okay, so now we're looking at C and D, so the last two graphs. So the relationship for C, like we talked about, decreases at a steady rate, and it's linear. But then on graph D, it decreases, and then it kind of curves, like it's gonna start coming back up, like your points are gonna go up from there. Decreases, then increases, or it starts to increase. There's a curve. Then last one, number 6, contrast the relationships represented by X and Y for graph B and D. So now we're looking at B and D. So for B, it was increasing by a steady rate, and it's linear. We can draw a straight line through it. D, on the other hand, decreases, then increases. Okay, decreases, then increases. It starts curving back up. Okay, so multiple choice problems, more like what you would see on a test. Number 1, look at the graphs. First of all, when I look at these, I can draw a pretty good line, a trend line, through the middle of points on both graphs. So they're both going to be linear, so keep that in mind. So which of the following is true for both graphs? A says both graphs suggest a nonlinear relationship because neither graph contains a line. Well, that's not true because I could draw a pretty good line through both of them and it wouldn't curve. B, both graphs suggest linear relationships because there appears to be a constant rate of change in each group. Probably. Both graphs suggest a nonlinear relationship. No. And D says there's not enough information to given to draw conclusions about the graph. That's not true. We have plenty of information. Okay, and then number 2, which of the following is not true about the graph of a linear relationship? Not true. So not. We're looking for one that's not going to work. F, the relationship is represented by the equation y equals mx plus b. That would be true because that is a linear equation. So that's true. G, the data appears to be increasing or decreasing at a constant rate. That would be true. I guess I should put an X mark on these since we're looking for one that's not true. H, the relationship may be proportional or non-proportional. That's true, depending on if you have a y-intercept, it could go through the origin or it could not. And then J, the relationship may be represented by an equation other than y equals mx plus b. No, that is not true. This is your equation for linear equations always. That's the format. There is no other type of equation. Then number 3, look at the scatter plot. Which of the following is true? Okay, so the first thing I need to look at is the graph. So it's not going to be linear, and that's only because it curves. Like my points go up, they increase, and then they decrease. So keep that in mind. So we want to know that it's nonlinear. So which of the following is true? Number 1, the graph suggests a nonlinear relationship between x and y because there is not a constant slope. That's true. We just said it was nonlinear because there's not a constant rate of change. It goes up and then it goes down. 2, the graph suggests a nonlinear relationship between x and y because the line appears to be curved. That's true. G, the graph suggests a nonlinear relationship between x and y because the relationship cannot be expressed by y equals kx or y equals mx plus b. So that's also true because since it increases and then it decreases, we couldn't have an equation. Okay, we couldn't make an equation because there's not a constant rate of change. And so then let's check 4. The graph suggests a nonlinear relationship between x and y because it appears to pass through the origin. Well, I can't really tell, but I'm going to say that it does not pass through the origin. So we're looking for which of the following is true, 1, 2, and 3. So C, 1, 2, and 3 only.